I'm Mark, and this is a video on how I converted my lathe to CNC. Now the scope for this project was to convert a lathe to CNC that could be used with Mach 3, but also at a flick of a switch be able to be used in manual mode. So after consulting with my nephew, who was an electronics engineer, we decided to use encoders to mimic the drive wheels for your X and Z axis through Arduino. So this is a video sort of on how I drew it up first in CAD. Then I moved the files or the components that I drew in CAD to allow it to be CNC'd. I saved them as IGES files, moved them across to Fusion 360, used Fusion 360 to lay down the tool paths, ready for machining. Then I machined the components with my Mach 1100mm, and then I'll fit them to the lathe, and then I suppose we'll breadboard the the Arduino and do a bit of testing, and then organise, get the software written. So that's what this video will be first. I'll take you to CAD, I think. Yeah, take you to CAD so that you can see how I drew the components up. Then I'll just do a bit of a quick demo on Fusion 360 to show you what that's about. So that'll basically sort of be part one of this project. Well, it might be as far as assembling the parts. I'll see how I go. But anyhow, we'll move across to CAD now.
Okay, here we are in CAD with the bed of the lathe. I drew the bed and the cross slide up and the chuck spindle. So I've only drawn the bits that I required to fit or design the CNC components to fit to it. So I'll just turn on the CNC components, or the components I made to CNC the lathe. There they are now. I'll get rid of the bed out of the way so we can have a bit of a better look around. Okay, so these are the components that I've had to make or will need to make to turn the lathe into a CNC machine. So I'll quickly run through them. On the back here of the chuck shaft is an encoder nut with an optical sensor to sense the position of the chuck for such things as thread cutting. Mach 3 needs to know the position to do thread cutting and so forth. Here we have the X-axis stepping motor and the mounts associated with the ball screw. And we'll just flip it up now. Before I flip it, just inside here, there's two timing gears that I'll have to make to drive the Z axis, and it's driven by a stepping motor which is in under here. So there's the stepping motor that drives the Z axis fitted in under there. Then we have our limit switches, one on each end, and a homing switch which will be triggered by this block of aluminium here. Then on the front here we have the drive wheels for the encoders, Z axis, X axis. They drive the encoders in the back here. Encoders fit in the back. I'll just there we go. Hide selected, so you can see the encoder fits into this wheel, and then inside in the back here I've fitted a little rare earth magnet, so it'll rub on this steel disc here to create drag so that the encoders don't freewheel. Otherwise, if you bump them, they would just take off. So then we'll just move, I'll just move around the back here, get rid of these. And round the back we have this plate here, which will support the Z-axis limit switches. And then up the top here we've got these steel plates which will be fitted onto the slide to allow it to be driven by this ball screw. The ball screw nut, the Z-axis ball screw, I had to fit on the outside because it wasn't it was too big, sorry, to fit inside here, so I've mounted it on the rear. Yeah, so that's pretty much how I drew it up in IronCAD. Then I took all these components and saved them as IGES files, then moved them into Fusion 360 and laid down the tool paths in Fusion 360. This back plate here, I had laser cut out of 8mm steel. I just thought it would be the best way, a nice solid plate to work off. So there we go, there's the lathe, or what I'm planning to do with my lathe, to turn into CNC. So I'll now move quickly to Fusion 360 and just give you a brief rundown on that. Okay, here we are in Fusion 360. I'll just run over this really quickly. I brought the parts into here, as I said, as IGES files to lay down the tool path. I didn't draw it in IronCAD because I'm not that familiar with Fusion 360 at this point, so I drew it in IronCAD and then brought them across because I wasn't comfortable yet drawing them and assembling them in Fusion 360. So I'll just quickly bring up a couple of parts, do a couple of demos of cutting or running the toolpath in simulation. There we go. Here's a simulation of these parts being cut. Bring the stock on and reset it and play. I'll just run it nice and quick. Leaving some tabs so it doesn't fly out. That's yeah, so it's a really nice software. If you haven't tried it, get it and give it a go, because I think you'll really like it. So that's all I'm sort of going to do with Fusion 360 at the moment. But yeah, that's how I cut the components in Fusion 360. Okay, these are the components. They're all cut. Here's the X-axis stepping motor, Z-axis stepping motor with the plate that supports it. So that plate supports the Z-axis. Then we have the encoder here, which fits into the Z-axis. Then these discs here, I'll just turn it over. So these discs here fit on the front, like I was describing, and then you have two little rare earth magnets, these little magnets here, that fit into these holes here and here, that then when this disc is mounted in place, they create drag to stop the, as I said in the earlier, to stop the encoder from freewheeling. So here's our Z-axis ball screw nut, timing gears, which I machined. I made a bit of a mistake on these. I machined them both without any guide on the side, so I had to machine these guides up to mount. They mount on like so on the side of it to stop the belt running off. There's your X-axis drive wheel and your mount for your Z-axis ball nut. And then over here, this is the part here that I showed you earlier on in Fusion 360 being cut out. So that's that component there. That holds the Z-axis limit switches. So that's pretty much all the bits ready to be assembled. Now I'll just come around to the lathe now. So down on the floor here, you'll see this is the gearbox that I took off here. So I took that gearbox off this part here. That was the main drive gearbox. Then I removed this gearbox arrangement from the cross slide. So they're both gone now. You can see the backing plate. The backing plate is now fitted here. So that's your backing plate right along, the 8mm backing plate that I was talking about, with your X-axis ball screw. That I've already fitted this because it's quite heavy and it took quite a bit of time to get it into place. And then we'll go around the back of the chuck and I'll show you the encoder nut. So if you come around the back here, this is the encoder nut that I machined and the optical sensor. So the encoder nut, as I said earlier, is used to tell you the position of the shaft as it spins. So you can do things like thread cutting. I made a blue here. I actually machined the first nut with a right hand thread. A bit silly really, but of course it's left hand thread to stop it from spinning off in normal operation. Anyhow, the first one was good practice. So yeah, we make some silly mistakes, that's one of them. Okay, so that's it assembled. I'll just run around a bit closer for you so you can have a look. So that's your front, your Z and X access controls. Just turn them. They don't run on because of the magnets. They don't free spin. Coupling. Come around the back. Limit switches. All moves quite smoothly when I move it. Quite happy with the movement. Okay, I've got the Arduino set up down there. Got a potentiometer to control the speed of the feed, and one little push button at this point just to make the X-axis drive in one direction. And then I've got the driver for the stepping motor just sitting there on the lathe. So that's it sitting there. And it's just connected up to the stepping motor. So here we go. This is the trial. First go at running it. So we'll see what happens. So here we go. I'll give it a try. Bring the power back on again. Reset it. So that's as long as it would take in normal situation if you wanted to use it manually. I haven't got any handle on this at the moment, so I'm just using a little hex screw. Here we go, look at that. We can change ratios in software, so it's just mimicking. You can see here, it's just moving away from my hand, moving towards my hand. Beautiful. And it's moving like within I reckon a micron. It's just as I'm moving it, it's just mimicking the movement of my hand beautifully. So now we'll try the feed. So we've got a little potentiometer here to set the speed, and a little button, as I said. So basically all you would do, eventually I'll have these buttons mounted up here somewhere. So I'll push the button now. There we go, look at that. Beautiful. Now I want to slow the feed down. So I can slow it down or speed it up. Oh, look at that. Fantastic. And then as soon as if I'm feeding and I start to drive it, it'll ignore it. But if I'm driving it manually, like so, winding it back down the bed, and I hit feed, it'll just take over. So of course your ratios you can change. That's the beauty of doing this in software. Your ratios will just change, so you won't have to crank it at this speed. You can set it up, you know, my nephew will be able to set it up exactly the way you want it. So there we go, we're winding down now beautifully, and you can just smooth as, absolutely beautiful. And then we go for a feed, manual feed, nice and slow. If you're doing some, facing something off, you just wanted a really nice slow feed, there you go, it's beautiful. We'll speed her up, and we can we'll get these speeds faster. I mean, this is just the absolute preliminary test at the moment. We need to review all the software, and there's a lot of work still to go. But anyhow, I'm pretty happy with that. She's up and running in its test mode. So next thing will be, I suppose, wiring it and setting it up. So yeah, I'm wrapped. Fantastic. I found a problem with this coupling, so I'll just go over what I discovered. Okay, I've got a dial mic set up here now, so you can see it moving. Now, I noticed, like, that's me turning it clockwise, and then I go anti-clockwise, and there's a bit of lag there, like backlash. And I'm thinking, where's it coming from? And I couldn't figure it out at first. Then I realised, so this is something that you want to keep in mind if you're building a lathe or any CNC machine. See this flexible coupling on the stepping motor? I don't know whether you're going to be able to see it on the video, but basically it's flexing. So that's going one way, come back the other. And if I turn it by hand, you'll see what I mean. By hand, see the flex? That's where it's coming from. So I'll have to redesign that. Looks like it's going to have to be some sort of solid coupling, because it's definitely giving it backlash or lag.